Hello everyone, welcome back to my YouTube channel. In this week's video, we are going to discuss chapter solution. I've already prepared 9 different questions that cover all the topics in this chapter. So let's get started. Question number 1. 15.2 milliliter of 0.425 molar sodium hydroxide is required to neutralize 25 milliliter of sulfuric acid. Determine the concentration of sulfuric acid solution used in this reaction. In order for you to answer this question, the first thing that you need to do is you need to be able to write the balance equation for this reaction. In this question, it requires the reaction between sodium hydroxide and also the sulfuric acid. Alright, in this reaction, we have sulfuric acid which react with sodium hydroxide. So because this is an acid and base reaction, so you shall produce salt, so Na2SO4 and also water. Right, the next thing that you need to do is you need to balance up this equation. So basically you have 2 sodium here, you need to put 2 sodium here. So looking at your oxygen, you have 2 oxygen plus another 4, so a total of 6 oxygen that you need. So we are going to look here, you have 4 oxygen, so you're lack of another 2, so you need to put 2 over here to make sure that your oxygen is enough. And then you need to check your hydrogen, 2 times 2 equivalent to 4, and then here you have 2 hydrogen here, and 2 times 1 is equivalent to 2, so a total of 4 hydrogen. So this is a balanced equation for this reaction. So now we have the balanced equation for this reaction. We need to look at what other information is given to you in this question. So basically you were given the molarity of sodium hydroxide. So molarity is equivalent to mole over liter. So molarity of sodium hydroxide given to you is 0.425. So from here we can have the number of mole of sodium hydroxide so that we can predict how much mole that we have for sulfuric acid. So basically the volume for sodium hydroxide given to you is 15.2 milliliter. So we need to convert this into liter, so you divide it with 1000. Therefore you get the number of mole for your sodium hydroxide is equivalent to 6.46 times 10 to the power of negative 3. So from here we are going to look at your balance equation. So basically for 2 moles of NaOH, so you shall need 1 mole of H2SO4. So now you only have 6.46 times 10 to the power of negative 3 mole of sodium hydroxide. So 1 over 2 times 6.46 times 10 to the power of negative 3. So basically you should get 3.23 times 10 to the power of negative 3 mole of H2SO4. So what else that is given to you? It states here it required, this much is required to neutralize 25 milliliter of sulfuric acid. So basically when you have the volume and you have the number of mole, you can find the molarity of your sulfuric acid. Alright, since the question wants you to determine the concentration of your sulfuric acid and you already know the number of mole and also the volume, so you can find the molarity is equivalent to mole per liter. So the number of mole for your sulfuric acid is 3.23 times 10 to the power of negative 3, and the volume is 25 milliliters, so you need to convert this to liter divided by 1000. You should be able to find the molarity of your sulfuric acid equivalent to 1.2920 times 10 to the power of negative 1 molar. So this is the final answer for the first question. Alright, let's move on to question number 2. Determine the volume of 0.6 molar hydrochloric acid to react completely with 2.5 gram of sodium hydrogen carbonate. So what we are going to do now is we need to write a balance equation for this reaction. So you have sodium hydrogen carbonate and also hydrochloric acid. So we're going to write sodium hydrogen carbonate react with hydrochloric acid. So you should get sodium chloride plus CO2, carbon dioxide, and also water. So from here, we need to look at all these elements, whether they are balanced or not at the reactant and also the product. So we have 2 plus another 1 oxygen here. So we have enough oxygen. We only have 2 hydrogen. So indeed we have 2 hydrogen. That's fine with that. So we have 1 Cl, we have 1 Cl here, and also we have 1 sodium on each side. Alright, so next up we are going to deal with this sodium hydrogen carbonate. Given in the question is the mass, so means that we can have the number of mole. So number of mole is equivalent to mass over RMM. So basically the mass is 2.5 gram and the RMM for this is, so you were given these values, so it's 22.990 plus your hydrogen is 1.0078 plus your carbon is 12.009 and 3 times 15.999. Therefore, you will get the number of mole is 2.5 divided by 84.0038. So the number of mole for your sodium hydrogen carbonate should be 2.9761 times 10 to the power of negative 2 mole of sodium hydrogen carbonate. Alright, so up next is we need to look at the ratio between the sodium hydrogen carbonate and also your HCl. So basically 1 mole of sodium hydrogen carbonate will need 1 mole of HCl. So because we have this much sodium hydrogen carbonate means that we are going to use the same value. Alright, since in the question we were given the molarity of hydrochloric acid and we already know the number of moles, so we can get the volume of this hydrochloric acid by using the formula for molarity. So molarity is equivalent to mole over liter. So the molarity is 0.6 and the number of mole is 2.9761 times 10 to the power of negative 2. So you can find the volume. Therefore, the volume is equivalent to 2.9761 times 10 to the power of negative 2 divided by 0.6. Therefore, the volume for your hydrochloric acid should be equivalent to 4.9601 times 10 to the power of negative 2 liter. So this is the final answer for the second question. Question number 3. Determine the ionic strength of a mixture of 0.1 molar of magnesium sulfate and 0.2 molar of calcium dichloride. Alright, so the first thing that we need to do is we need to separate this into ions. So we are going to start with magnesium sulfate. So we have Mg2 plus and also SO4 2 minus. And for the other one, calcium dichloride, so basically, if you don't know what calcium is, you should be able to know that chlorine is Cl negative. So since you needed 2 Cl, 2 chlorine here, therefore your Ca should be Ca2 positive. Alright, so since we have all this information, so we can use the formula of the ionic strength. So equivalent to half. So we have two different things here. So we are going to start with magnesium sulfate first. So 0.1 times, because you have 2 magnesium here, so 2 to the power of 2 plus this one is 0.1 again, times this one is -2, so -2 to the power of 2, and then plus you have 0.2, so 0.2 here times this one is +2 to the power of 2 plus, so you have 0.2 times this one is 1, so -1 to the power of 2. Right, so you will get the ionic strength is equivalent to 1/2 times 4 times 10 to the power of -1 plus 4.0 times 10 to the power of -1 plus 8.0 times 10 to the power of -1 plus 4.0 times 10 to the power of -1. Therefore, you get 1/2 times 2.0, so you will get the ionic strength is 1.0 molar. So this is the final answer for the third question. Moving on to question number 4, the ionic strength of a solution of 0.1 molar in ferric 3 chloride and in ferric 2 chloride with an unknown concentration is equal to 1.2. Determine the molarity of ferric 2 chloride. So, in order for you to answer this question, the first thing that you need to do is you need to be able to write this in the ionic form. So, we are going to start with the ferric 3 chloride. So, basically, this one will be Fa3 plus and your chlorine definitely Cl minus. So, moving on to FeCl2. So, this one will be Fe2 plus and the other one will be Cl minus. Alright, so now we can predict what is the concentration of the unknown FeCl2, the unknown concentration of FeCl2. So basically the ionic strength is given to you, which is 1.2. So your ionic strength is equivalent to 1.2. So you can write 1.2 is equivalent to half times, we're going to start with this FeCl3 first, so 0.1 times +3 to the power of 2 plus the same concentration times -1 to the power of 2 plus this one is X, unknown concentration, times +2 to the power of 2 plus the unknown concentration again times -1 to the power of 2. So you will get 1.2 is equivalent to half 1.2 plus 6x. Right, so to make things simpler, I'm just going to transfer this here, so you will get 2.4 is equivalent to 1.2 plus 6x. So basically 6x is equivalent to 2.4 minus 1.2, therefore you will get 1.2, and then your x is equivalent to 1.2 divided by 6, so your x is equivalent to 0.2. So the unknown concentration for FeCl2 is actually 0.2 molar. Let's move on to question number 5. Determine the delta H of the reaction if the KEQ at 1.727 times 10 to the power of 3 degrees Celsius and 3000 Kelvin are 0.782 and 8.614 respectively. Right, so in order for you to answer this question, we need to recall back our formula. So our formula is ln K2 divided by K1 is equivalent to negative delta H divided by R, so times 1 over the final temperature minus the initial temperature. Right, so another thing that you need to look at is the value of R that you're going to use. So in this case, the value of R that we are going to use is 8.314 and the unit should be joule over mole per Kelvin. So it means that the temperature should always be in Kelvin, therefore we need to convert this degree Celsius to Kelvin. So from here is 1.727 times 10 to the power of 3, so you need to plus 273. So you should get the temperature, the initial temperature should be 2000 Kelvin. Next, what we are going to do is we're going to plug in all the values that we have here. So ln K2, so your K2 is this one, 8.614 divided by your K1, 0.782 is equivalent to negative delta H divided by R, 8.314, and times T2. So your T2 is 3000 and your T1 is 2000. So from here you should be able to get 2.3993 is equivalent to negative delta H divided by 8.314 times negative 1.6667 times 10 to the power of negative 4. So from here, because this is negative and this is negative, so you will get your delta H is equivalent to 2.3993 times 8.314 divided by 1.6667 times 10 to the power of negative 4. So you just have to press your calculator and you should get your delta H equivalent to 1.1968 times 10 to the power of 5 joule per mole. So this is the final answer for your fifth question. Alright, let's move on to question number 6. 7.7320 times 10 to the power of negative 4 mole of caffeine was dissolved in 10.0 gram of camphor, hence decreasing the freezing point of camphor by 276.07 Kelvin. Determine the Van Hoff factor of caffeine if the freezing point depression of camphor is 39.7 degrees Celsius per molar. Alright, for this question, there are easy steps to know the answer. At first, you are just going to look at your substance. So your substance is caffeine, so definitely it will not dissociate completely. Therefore, you can say that your Van Hoff factor should be equivalent to 1. Just like when you use other solvents like ethanol, like any hydrocarbon, so your Van Hoff factor should equal to 1. But for this question, we need to check whether is correct or not. Your Van Hoff factor is equivalent to 1, so we are going to use the formula for the freezing point depression. So delta TF is equivalent to KF, molality, and the Van Hoff factor. So the first thing that we are going to do is to find the molality. So molality is equivalent to mole of solute divided by mass of solvent. So your solute is actually the caffeine, so given to you is in mole already, so you just have to plug in this value, 7.7320 times 10 to the power of negative 4 divided by the mass of solvent. So your solvent is Chem4, so it is 10 grams. So you need to convert to kilogram, so divide it by 1000. So you will get the molality is equivalent to 7.7320 times 10 to the power of negative 2 molar. Alright, so given to you is the freezing point depression. So the freezing point depression is 39.7, and then it says that hence decreasing the freezing point by 276.07 Kelvin. So we are going to, because this is the value of your delta T freezing, so 276.07 you need to minus 273.00, so you will get 3.07. So what we are going to do now is we are going to just plug in this value. So 3.07, your Kf is 39.7, and your molality is 7.7320 times 10 to the power of negative 2, and this is your Van Hoff factor. So basically your Van Hoff factor is equivalent to 3.07 divided by 3.0696. Therefore your Van Hoff factor should be equivalent to 1. So this is the final answer for your 6th question. Question number 7. Determine the freezing point of a solution of ethyl alcohol which contain 20.0 gram of the solute dissolved in 0.59 liter of water, given that the molar freezing point depression of water is equivalent to negative 1.86 degrees Celsius per molar. Right, so in this question you were given the mass for your ethyl alcohol. So ethyl alcohol is C2H5OH. So what we are going to do now is we are going to find the number of mole. So number of mole is equivalent to mass over RMM. Alright, so the mass of this ethyl alcohol is 20 gram, and the RMM, so if you don't know what is the atomic mass, you can refer to the previous question. I've already given you the molar mass for this substance. So you have your carbon is, because you have 2 carbon here, 2 times 12.009 plus you have 5 hydrogen, so 5 times 1.0078 plus 1 oxygen, 15.999 plus hydrogen is 1.0078. So from here you should get your number of mole is equivalent to 20 divided by 4.6064 times 10 to the power of 1. So the number of mole is equivalent to 4.3418 times 10 to the power of negative 1 mole of ethyl alcohol. Right, so up next, what you are going to do is you need to calculate the molality. So molality is equivalent to mole of solute. So this is mole of solute, 4.3418 times 10 to the power of negative 1 divided by the mass of solvent. So the mass of solvent, so it is being dissolved in 0.59 liter of water. So basically we know that 1 liter of water is equivalent to 1 kilogram of water. So we're just going to copy it. So 0.59 liter equivalent to 0.59 kilogram. So you will get 7.3589 times 10 to the power of negative 1. That is the molality, so molar. Right, so up next we are going to find what is the delta TF. The delta TF is equivalent to KF. So KF is given in the question, which is negative 1.86. And the molality is 7.3589 times 10 to the power of negative 1. And since this is ethyl alcohol, it should not dissociate completely, so your Van Hoff factor should be equivalent to 1. Therefore, your delta TF is equivalent to negative 1.3687. So the actual freezing temperature of water, because your solvent is water, so the freezing temperature is equivalent to 0, the actual freezing temperature. So now the new freezing temperature is equivalent to 0 plus your delta TF. So your delta TF is negative 1.3687 degrees Celsius. So 0 minus 1.3687 is equivalent to negative 1.3687 degrees Celsius. So this is the final answer for your 7th question. Let's move on to question number 8. Determine the mass of calcium chloride to be dissolved in 400 grams of water to lower the freezing point to 258 Kelvin, given that the molar freezing point depression of water is negative 1.86 degrees Celsius per molar, while the atomic mass of calcium and chlorine are 40.078 and 35.446 respectively. Right, so the first step that we need to do is we need to change the calcium chloride into its ionic form. So calcium chloride, CaCl2. So it means that your Cl is Cl negative and your Ca should be Ca2 positive, because you needed two Cl negative to balance out with the Ca positive. And then from here we can calculate your Van Hoff factor. So you have positive 2, so you have 2 plus negative 1, so 2 plus 1, doesn't matter the positive and negative. So your Van Hoff factor is equivalent to 3. So what else that you need to do is, when you look at the molar freezing point depression, the unit is degrees Celsius per molar. Therefore, this the freezing point is 258, so you need to minus 273. You should get negative 15 degrees Celsius. Alright, since that your solvent is water, means that the original freezing point is actually 0. Therefore, your delta TF is equivalent to negative 15 degrees Celsius. Alright, so we are going to move on to calculating the molality of this solution. So molality is equivalent to the mass of the solute. So mass of calcium chloride is what you don't know. So you need to divide with the mass of solvent. So the mass of solvent is 400 grams. So you have 400 grams here. So 400, you need to convert it to kilogram divided by 1000. So this is your molality, right? So what you're going to do now is you're going to plug in all the information that we have inside the equation. Delta TF is equivalent to KF, molality, and your Van Hoff factor. So from our previous calculation, the delta TF is equivalent to negative 15 degrees Celsius. So your KF is given to you in the question, which is negative 1.86 degrees Celsius per molar, and your molality is X divided by 400 over 1000, and your Van Hoff factor is equivalent to 3. So from here we are going to rearrange so that we can get the value of X. Alright, so to make it simpler for you, we can also write delta TF is equivalent to KF, molality, and the Van Hoff factor. So your delta TF is equivalent to negative 15, your KF is equivalent to negative 1.86, 86, and your M is the thing that is still unknown, while your I is equivalent to 3. So basically you can get your molality is equivalent to 2.6882. Alright, so molality is equivalent to the mole of solute divided by the mass of solvent in kilograms. So the mass of solvent is 400 grams divided by 1000. So we know that the molality is equivalent to 2.6882. So this one you bring up here, 400 divided by 1000. So this value should be equivalent to the mole of solute. So from there, we should be able to calculate the mole of solute should be equivalent to 1.0735. So this is your mole of solute. Okay, so let's look at the question again. The question asks you to find the mass of calcium chloride. So how are you going to find the mass when you already know the mole? So mole is equivalent to mass over RMM. Alright, so we are going to find the mass. So CaCl2 40.078 plus, because you have 2 chlorine here, so 2 times 35.446. So you should be able to get the mass equivalent to this value, 1.0735 times this one. You just need to press your calculator. You should get 1.1097 times 10 to the power of 2. Therefore, your mass should be equivalent to 1.1913 times 10 to the power of 2 grams. So this is the final answer for your 8th question. Alright guys, so we are now at the final question for the discussion for this week. So the rate constant of a reaction is 4.7 times 10 to the power of negative 3 at 298 Kelvin with a delta H of 33.6 kJ per mole. Determine the rate constant of the reaction if it is conducted at 75 degrees Celsius. Right, so the suitable formula to use for this question is ln K2 over K1 is equivalent to negative delta H over R times 1 over the final temperature minus 1 over the initial temperature. The next thing that you need to look at is the value of R. So your value of R is actually equivalent to 8.314 joule per mole Kelvin. So in this case, the temperature should be in Kelvin. This one is okay, but this one you need to convert to Kelvin. Another thing given to you, your delta H is equivalent to 33.6 kilojoule per mole. So this one is in kilojoule, but this one is in joule. So the rule of thumb is you never want to mess with your constant, so you need to convert this into joule instead. So we are going to do the conversion, and then we are going to plug in the value inside this formula. Alright, so what we are going to do now is we're going to plug in the value inside the formula. So now we have ln K2 over K1. So your K2, your ln K2 is X, and your ln K1 is this one. 4.7 times 10 to the power of negative 3 is equivalent to negative your delta H after the conversion of the unit is equivalent to 3.36 times 10 to the power of 4, and your R is 8.314, and then the temperature, so 1 over T2 is 348 minus 1 over T1 is 298. Alright, so here we can get 1.9485. So this is ln. So in order for us to remove the ln, what we can do is your x divided by 4.7 times 10 to the power of negative 3 is equivalent to 1.9485. So your x should be equivalent to 7.0183. So this one here we bring up there, so times 4.7 times 10 to the power of negative 3, so you will get your x is equivalent to 3.2986 times 10 to the power of negative 2. So therefore, from here we can get the rate constant of the reaction at 75 degrees Celsius is equivalent to 3.2986 times 10 to the power of negative 2. Alright, so this is the end for this week's video. So I hope that this video helped you to understand more in the solution chapter. So don't forget to subscribe and give a thumbs up if you think that this video is helpful. So I'll see you again next week. Take care and be safe. Goodbye.